Okay, it's 9 a.m., so let's get started. So today is going to be a little bit different. I'm first going to start off doing a lab debrief. So typically, if I feel like lab was meaty and there are things I want to talk about or want to have you guys talk about, then the next day we'll do a debrief. So we'll do that today. And then after the lab debrief, I want to take time now that everyone has had a chance to write code, compile code, have bugs and errors in your code and run it and all of that. I want to actually stop and talk a little bit about what's happening behind the scenes when you compile and when you execute your code and the different types of bugs or errors that you can run into. So today is going to be a traditional lecture, and I'll be sharing both my code, my BlueJ, and also I have a whiteboard here that I'll share as well. Okay, before we get started, it's not really an announcement, I guess, but I wanted to clarify that my expectation is that this class kind of flows from Friday to Friday, by which I mean this week you should be working on homework 2, which covers variables and operators, which is what we did last week. And there is no expectation that you've started on homework 3. And mainly I really have structured it so that you've done the reading, you've seen lectures, you've done multiple in-class problems, you've done the whole lab before you ever even start the homework assignment. And so the idea is that today you'd finish homework 2 and turn it in and start homework 3 on methods. So if you started homework 3 early or felt like, oh, I think I'm supposed to be working on it, you may have been frustrated or found that, okay, I don't quite understand. And that's totally reasonable because I've kind of structured it so that you start on Friday. So you start on Friday, turn it in, start the new one on Friday, and that before you start a homework assignment, you've done a lot of reading, practice, lab, so on and so forth. So just to clarify that. Okay, so I want to do a lab debrief, and the reason why, so a few things. So you may have noticed that I was in your lab group yesterday, and I think next week and maybe the week after, I just want to sit in on people's lab groups because I want to kind of immerse myself and get a sense of what the experience is like. So I'll be joining your lab groups silently and just doing my own work. It's actually kind of helpful to just have like a work group. Basically, I just want to get a sense of how lab groups are going and if I want to make any changes. And so you may see me pop in. Feel free to ask me for questions. I'm just going to be silent, but if you have questions, I'm more than happy to help. Interestingly enough, one of the lab groups I got a chance to join, I got a chance to see people's code. And I was really, really, really surprised that of the 3 people, each person came up with their own conception of what these methods were supposed to do, what their roles were, how to use them, wrote them, but maybe didn't use them. It was really interesting that every single person had a completely different way of conceptualizing yesterday's lab. Very, very interesting for me, at least. So what I'm going to do today is I'm going to show you my lab and what I did for lab. Please unmute and ask questions as I'm kind of giving you a running commentary. You can ask questions about why did I do a certain thing, or could we try something if we did this, what would happen? So any sorts of questions. And so I'm going to show you my code, give you a commentary on it, and then hopefully that'll be like enlightening as you start the homework assignment today. And the homework assignment is asking you again to write and structure these methods. So hopefully that will be of use. Okay, enough talking, let's do this. Okay. Okay, so here's my lab 3 compound interest, and I'll just open that up. Okay, so starting from the top, here's my java.comment. I have a sentence description, my @author and @version tags. It's kind of basic public class compound interest. Okay, so there are 3 methods here: yearly interest, print 10 years, and then my main method is here at the bottom. And the lab write-up said, write a method called yearly interest that takes in some amount of money and computes the resulting amount after we add in a 5% interest and returns that answer back. Okay, so here's my method that does that. So I have a method called yearly interest. It takes in some amount of money. And since it's money, I think a double is appropriate because there might be some change. So some numbers after the decimal point. Given some amount of money, I decided to have my interest rate be a variable declared inside this method. And a lot of people passed in their interest rate. That's another way of doing it. And it's probably a better way because notice for me, my interest rate is hard coded. Every time you call this method, it will always be 5% because I hard coded it. So it would kind of be nice if you pass that in as well. Given the amount and the interest rate, I then compute the resulting amount using our equation, and then I'm returning back the resulting amount. So that's this method, yearly interest. It computes the interest for a single year. And once you have such a method, from that point on, you don't have to reinvent the wheel. So you don't have to compute this equation anymore. You can call the method, pass in an input. The method will compute it, the answer, and return it back to you. Okay, looking at this method, one common thing I saw yesterday that in fact I see every single semester, so it's also very interesting to me, is the following. Okay, so I saw a lot yesterday of hard coding the value of variables. And again, this is super common. And I think why students feel compelled or drawn to do this is because methods are the first concept we're going to see where we are teasing out or we're separating the specific numbers that we're working with, and we're separating those from the kind of abstract equation that we're working with. And up till now, like when we did printing or variables, they were always the same. I had a variable and I gave it a number, and then I used that number to compute maybe a heart rate or whatever. And there's something cozy and very comforting about that because numbers keep us grounded and specific examples keep us grounded. But with methods, I'm really asking you, or methods are forcing you to separate those two, that there's the specific numbers, which are very comforting to us. And then there's the abstract equation or the abstract algorithm. And so I often see students do this because we feel more comfortable doing this, giving numbers to our variables so we know what's going on. And so you're going to have to like squash that instinct within you and just trust. Okay, so there's kind of some trust involved with methods. This method is a general equation, and we don't know where the numbers are coming from yet. And we have to kind of sit in that tension a little bit and not give in to the desire to hard code numbers. Okay, so once I have my yearly interest method, then I started on my print 10 years method, and the lab write-up said, okay, make a method called print 10 years that takes in the starting amount, and then it's going to compute and print out the amount in your savings account every year. So I'm starting off just by printing the starting amount, and then here we go. So this is the first time I call yearly interest. Okay, so I call yearly interest. I pass in the starting amount. Okay, if we were like looking at the flow of execution, the computer jumps up here and it executes all of this and it returns back the answer. And I'm storing that answer in a variable I called total. And then I'm printing it out. So that's year one. Okay, one call to yearly interest computes the amount after 1 year. And then I'm printing that out. And then every year after that, it's exactly the same thing. So for every year, I'm going to call yearly interest and pass in total. And then it'll return the answer. And I'll print the answer out. And then again, I'm going to call yearly interest and I'll pass in the total amount of money in my account. It'll compute the answer and I'll store that back in total, and then I'll print it out. Okay, so you'll see I kind of did that, just kind of rinse and repeat for 10 years. And that's basically it. So some things to note, many people had one variable for each year, and that's totally fine. Like that makes sense too. So you could say like double year one equals, and then call yearly interest. Double year two equals, and then call yearly interest and pass in year one. and then double year 3 equals call yearly interest and pass in year 2. So if you had one variable for each of the years, that's a great idea. And I actually think that makes it clear, right? It makes it clear kind of the flow. We take in year 2, we get out year 3. We put in year 3, we get out year 4. So I actually kind of like that idea. I'm just being a bit parsimonious and just kind of having one variable, but that's a good idea. Also notice my method here is void. There's not really anything to return back. The purpose of this method, and that's why it's called this, is just to print stuff. And when we print, that's quite different from actually returning back. So this method just prints information to the user. There's not anything we need to communicate back to the main method. So I made this a void method. Okay, again, at this point, we still don't have numbers though, right? This method, again, it's an abstract encapsulation or an abstract world. You give it an input, it does its job, but we don't actually have any numbers yet. That happens in main. Okay, so it's in main that for the first time, I have an actual number. And so I'm calling print 10 years, and I'm passing in an actual number, which is $100. There's $100 in my savings account. Or we could pass in $500. Okay, so that is a general pattern. It is in main where you start the process off. So it's in main that you actually have actual numbers or actual strings, and then you pass those off to the methods you've written. The methods go out and do all of this work, and then they come back, right, having accomplished what they were meant to accomplish. So for this homework assignment going forward, keep that in the back of your mind. It's often in main that we have actual data, actual numbers. Our methods, though, are abstract equations, or they're abstract algorithms. And we rarely hard code things in our method because we want them to be general purpose. And then the last thing I wanted to comment on is string args. I see a lot of people making methods and the input to your method is a string args. We don't know what that means yet. You certainly don't know what it means. I know what it means, but you don't know what it means. You should never write a method where the input is something that you have no idea what it means. So string args is specific to the main method, right? The main method has a very specific header, public static void main string args. When you're writing your own methods, there's no need to use string args. If you don't know what it is, then clearly you definitely should not be using it. Okay, so we don't need anything like, you know, so yeah, if you don't know what it means, don't use it. Also private, right? We haven't really talked about that, so you can be assured that there's no problem I will give you to solve where the solution involves using private or involves using string args or involves using a for loop. If you go to a tutor and they're like, use a for loop, I am giving you permission to tell them, we have not learned that yet. That's not helpful. Or if they tell you any concept you've not learned, we have not learned that yet. That is not what I'm supposed to do. Okay, so rest assured you never need to use something we haven't learned yet. Okay, so I'm going to scroll up and I'm going to just let you look at kind of this code here. And I want you to sit there for 30 seconds, 60 seconds, and look at this. Any questions? Okay, so let's just take some time to think about questions. What if we did this? Why did you do this? Any questions?
I have a question.
Mm-hmm.
I noticed that like when you were writing your code and you managed to get it all to come out at the end, you didn't have to use a return statement. When I was writing code for like a similar problem with on the homework, whenever I was like having it like compute like all the like the heart rate stuff and all that, at the end it kept saying it needed a return statement.
Okay, yeah.
But
so that means that
it's
here, so you as the programmer get to, you know, write your method. This is where you indicate the return value. If you don't put void, if you put double int string or anything else, when you go to compile it, it will tell you, you need a return value. And so that's an indication to you that this right here doesn't match what you think it should be. And a kind of a general rule is if you have a method whose only job is just printing, it should be void then. Yeah. All right, keep looking at this.
I have a question.
Yeah.
I tried to do this yesterday in the lab because at first I thought I wanted to have the interest rate in both yearly interest and print 10 years.
Okay.
So I was like, oh, can I just put the final double interest rate in the class, but not in either of the methods, that I could refer to it in both of them? But that didn't work. And I was wondering why.
Whoa, that's mind blowing. Okay. Okay. So what Anna's saying is she wants to be able to refer to the interest rate in more than one method, in yearly interest and in print 10 years. So she had an idea, maybe she could take this variable and she could move it here. So it's kind of floating in the class, but maybe it's not in any specific method. But notice when I did that, now I get an error, right? It says a non-static variable interest rate cannot be referenced from a static context. So we'll see in like 2 weeks' time, we actually can do this. You can move your variables outside of the methods, put them in the class. Once you do that, every method can use that variable. Please do not do that, only because it requires a little bit of thought and sophistication. And so, for example, right, just naively moving it out, you get an error. And I'm not going to solve that error for you because I don't want anyone doing that. I'm kind of nervous, but it was a great idea. It can be done. We will see how to do it, but we're going to wait so that we don't get things out of order. Yeah. Okay, but that raises a really good question. And I'm going to pose this question kind of to everyone. Let's say that I wanted to, instead of hard coding the interest rate, I wanted to be able to set the interest rate to different values, 5%, 7%, crazy 10%, really low 1%. That means that starting in main, I somehow need to thread this new variable from interest rate. I have to weave it through all of my code. I'm going to have to change my code so that everyone's communicating this variable. Okay, almost like a game of telephone, right? Like I pass the variable from main to here, from here to here. Okay, how would I do that? So let me make that more specific. Looking at these two methods, what would need to change if we wanted to not hard code the interest rate, but we wanted to pass in the interest rate? Okay, so what would need to change?
I did that in my code, and what I did is in the print 10 years
Okay.
parentheses for that method,
Yeah.
I had a comma and then double interest rate.
Okay.
And then when I referred to it in the main method, I had the starting value, comma, and then the interest rate.
Perfect.
And
Okay.
then I specified it in the main.
Okay, so that's the first step, right? When you're coding, you're kind of thinking about hooking things up. Okay, everything has to match like a puzzle. So I've changed the method header so that now I'm taking in two things and they're both doubles. So that means I have to back up in main where I called that method. I now need to provide two things and they both need to be doubles. Okay, so here's my interest rate. So now I have a number and it's being passed in up here. What would we do with it? We got it this far. Okay, so how do we take it and actually pass it on? Yeah, really spend time thinking about this. We're like going to sit here for a bit, right? Because this is kind of an important concept with methods, which is how do you kind of get information to flow Or how do you weave it throughout your code? Like you pass it in and then what do I do with it? And how do I pass it on? Okay, so we're gonna sit here for like 30, 60 seconds. And I really want you to think, what do we do with it now? Right, how do we pass this on?
Do you mean to the yearly interest main method?
Yes. So one,
Well,
I guess, recognizing that we have to pass it on to the yearly interest method. And then two, how would we do that?
well, I noticed that you have yearly interest parenthesis starting amount
Mhm.
set equal to the total. So I presume that you would probably do a similar thing to before as parenthesis interest rate, and in the yearly interest method effect represent the fact that you're going to be taking in two variables in that method as well.
Perfect. Okay, so Kelsey's saying exactly what we did before. We just want to do it one more time. Okay, so we've gotten our interest rate this far. So we're taking it in. Now we need to pass it to yearly interest. So let's pass it to yearly interest. So now I'm going to pass in the starting amount and the interest rate. Okay. We should get an error for this because, right? Okay, so this is a good error. Someone had this during lab, and so this is one you're going to get a lot. It's in the method yearly interest cannot be applied to these given types. The method requires a double, and you have given me two doubles. So the actual arguments and the formal arguments differ in length. Okay, so it's saying you cannot apply two doubles to a method that requires only one double. The actual arguments and the formal parameters are differing. Okay, so indeed, so we passed an interest rate, but we forgot to update our method. So let's go back and put in interest rate. Okay. So now we've hooked that up. And now inside of here, we don't need this hard-coded value anymore. We're going to use the value that's passed in by the user. So at this point now, I mean, we still have a few more errors, but at this point now, we've made our code much more usable. Instead of hard coding 5%, now in here in main, we can change this number to whatever we want, 7%, 10%, 1%, right? And that's being passed in here, which gets passed in here, which goes up to here, which we now use in our equation. Okay. Now we do have some errors. Because I called this method 10 times, I now have 9 errors, and I have to go through and copy and paste this into each one of these. And I'll tell you right now, this is a sign of kind of bad programming, but it's all we know right now. Okay, so that's kind of how you would hook up if you wanted your interest rate to be variable. Also, the second part said, okay, what if I wanted to save $60 a year? You would go through exactly the same steps. So you'd say, okay, I now want to pass in another input. I want to pass in 60. So I have to come up here then and modify this. Okay, and then I want to take that and pass it into here. Okay, so then you'd have to modify this and this. Okay, so you need to go through and hook everything up and make sure that you're matching all of your types, right? And everything aligns. Okay, final questions.
So just as a reiteration, sorry, I'm just gonna. So you like once you add something into like one method, you have to add it to every single other method so that it all matches, so that it can be able to print something out at the end in the main method, correct? Sort of deal.
Kind of. Okay, I'm going to say yes with a slight rephrasing of that. In this specific example, I had to pass it into one method and then pass it into the other method because of the way we set up our methods, right? Like print 10 years calls yearly interest. So yes, in this particular example, where that's kind of the design, everything you said is perfect. If we move on to something else where we wrote two methods, but they're completely independent, they never talk to each other, Then you just have to in main pass in your number and just modify one method. So it kind of depends upon, do your methods need to call each other or talk to each other? And if so, yes, everything you said is perfect. Yeah. Any other final questions, clarifications, ways that you think about this that you want to check? Is this a good way of thinking about it? Okay. Okay, I'm going to introduce an error into this code. So I'm just going to get rid of the savings. We didn't really do anything with that. Okay. So I want to spend our remaining like 30 minutes, 25 minutes, and I want to show you behind the scenes what happens when you compile and run your code and the sorts of errors that you can get. And so I'm actually going to introduce an error. This was an error from homework 1, and many of you predicted that this should be an error, and then you ran it in BlueJ and everything worked fine. And it was a little kind of like, huh, that's kind of weird. So I'm going to change the name of the main method to man. Okay, so you know what? No, I'm not going to do that first. First, let's just see what happens when there's no errors. Then we'll introduce an error and we'll go from there. Okay. Okay, so I'm going to pull up for you my directory where this code is saved. And there's 2 ways of doing that. We're most familiar with this, which is going to the Finder or your window here. For me, it's in teaching. I have what I call my workspace, my labs, lab 3, method execution. Okay, so here's the code that we're looking at. Now, another way of doing this, and when I started computer science, these sorts of windows did not exist yet. And so we had to use what's known as the terminal. Okay, so this is called the terminal. And it's a kind of a old school way of navigating and interacting with your code. Let's see. I can type PWD, which stands for print working directory, and it will tell me where I am. Right now I'm in my home folder. Okay, so I'm going to navigate to this same directory. So it's in my documents, teaching. I have a workspace for this class, semester's worth, labs, methods, method execution. Okay. Okay, so I'm going to list all the files, and here we go. Okay, so this terminal and this Finder window are looking at the same directory. Now, you'll notice that for my compound interest.java class, there's also a compound interest.class. And that is the compiled version of your code. So every time you hit the compile, you're actually creating what is known as a class file. Okay, so I'm going to remove the class files. Okay, so we have no more class files. And this is our code. So I'm going to open up compound interest just to show you. So this is the code we were just looking at. Okay, I'm going to compile this. I'm going to compile it not through BlueJ, but I'm going to compile it in the terminal at the command line. So there's a program called Java-C for Java compiler. And I pass in my program, compound interest.java. Okay, it compiles it. And so now you'll see that there are these .class files here. This is the compiled version. We can open that up to look at it. Okay, this is what it looks like. It's not human readable anymore. It's kind of this weird representation of symbols, but you can see some strings in here after 2 years. But for the most part, it's not really human readable. And this is called bytecode. So this is an intermediate representation called bytecode. Okay, so I just compiled. I took my Java file, I compiled it, I got my class file. The class file is not human readable. Now I want to take my class file and actually execute it. I want to run it. And so we could say Java, and I pass in compound interest. Okay, and I'll hit enter, and there we go. Okay, so this is now the console, and it's displaying the answers right here. All of that is familiar. That's kind of what you're doing in BlueJ. Every time you hit compile, you right click, you choose main, and you run it. And I've just shown you how to do that from the terminal. Okay, now let's introduce an error. So I'm going to go back down here, and I'm going to change this main to man. Okay, and we're going to do that process from the start. So I'm going to remove all of the class files. Okay, so all we have is compound interest.java. let's compile it. Compiled just fine. So in terms of compiling, it is okay not to have a main method. Okay, now I'm going to run it and we get an error. Okay, so it says main method not found in class compound interest. Please define the main method as public static void main string args. Okay, so this is an example of an error that doesn't happen during compile time. It happens at runtime. Okay, this is known as a runtime error. And BlueJ, because it's meant for beginners, BlueJ totally circumvents this and allows you to run code even if there's no main method, right? You can right click and you can choose to run whatever method you want to run. And that functionality really only exists in BlueJ, kind of in the real world, I guess. Any Java program, there has to be a main method somewhere, or else the computer doesn't know where to start. So this is our first example of what's known as a runtime error. Okay, so I'm going to switch to my whiteboard now, because what I want to do is I want to draw a picture for you, or a flow chart of everything you're doing from source code to your .class file and then running it, and the different types of errors that could happen from a compile time error all the way to this, a runtime error, and then there's something known as a logical error. Okay, so let me just stop any questions before we delve into actually taking notes. Any questions?
Will we need to use the terminal to like know how to use that?
You
for
won't, no.
class?
Nope, not at all. Yeah. It's kind of nice being able to, though, but no, you will not have to. Yeah. Okay, so let's draw out for ourselves so that at this point going forward, everyone has a good sense of what you're actually doing and the sorts of errors that can come up. So I'm going to share my screen. And you're going to need a notebook and a pencil or paper. Hopefully the notebook that you use for your video lectures is handy. Okay. Okie dokie. So I want to talk about compiling and executing your code. And we're going to draw a picture that just illustrates the process that I went through on the terminal, which is the same process you go through in BlueJ. Okay, so everything begins with what we call source code. Okay, this is what you write in BlueJ. Source code is human readable, and it's called source code because it is the beginning of everything, right? It is the source, it is the start. So you sit down, you write some source code. At some point, you will compile it. So that is a program called the compiler. The compiler is actually literally a computer program. It is a computer program that takes as input another computer program. And then it basically scans through your computer program, your source code, and just makes sure that you have no syntax errors. Okay, so the whole point is to check for syntax errors. Now, all of you are very familiar with the compiler because at this point, you're probably getting lots of syntax errors. Okay, so the compiler may kick your code back and say, sorry, you've got some errors. Do not pass go, do not collect $200. So you have to go back. However, assuming that you do not have any syntax errors, what the compiler produces is what we saw, the bytecode. Okay, so it produces these .class files. And there's going to be one .class file for every single class that you've written. So the compiler may, in fact, output multiple .class files, one for each class that you've written. Right now, we've only been writing one class, but pretty soon we'll be writing multiple classes that are all interacting with each other. In addition, we need not just the class files for the code that we've written, we need the class files for any code that someone else wrote that we are using. And a perfect example of that is system.out.println. So we're using that code, we're calling the println method. Somewhere on your computer, there's a folder called Java. Inside is a subfolder called lang for language. And inside is a file called system.java. And inside of that class, there's a method called println. So all of this is hidden to you, but basically when you run your code, you need not only your .class files, but you need the .class files for system, or else you can't call that method. Okay, so there are your .class files, but there are also what are known as library files. Okay, so these are library.class files. Again, there may be more than one of them, kind of depending upon what you're using. Together, all of these are combined and passed into a program known as the Java Virtual Machine, or the JVM for short. Okay, the Java Virtual Machine, otherwise known as the JVM. So on the command line, when I compiled and then I ran the code by saying Java, and then I gave it compound interest, that was the Java virtual machine. So I was starting the Java virtual machine. In BlueJ, every time you right click and you hit main, you are starting the Java virtual machine. The purpose of the Java virtual machine is it translates bytecode into machine specific instructions. So these class files are bytecode. Bytecode is machine independent. And what I mean by that is I could write some very nice code and I could compile it into .class files, and then I could email it to you for you to use. And even though I'm on a Mac and you may be on Windows, it doesn't matter. Bytecode is machine independent. It's written in such a way that it doesn't matter what machine you're running on, bytecode is universal. And the way bytecode works, or the way Java takes bytecode and runs it on your machine, is this ingenious idea known as the JVM, and it translates. So I have a JVM for my Mac, and you may have a JVM for your Windows machine. And maybe if you're running Linux, I highly doubt it, but you may have a JVM for Linux. Okay, so that's why when you downloaded BlueJ, you had to choose what computer you were on, because each of us has a JVM specific to our machine. So my JVM takes in bytecode and it outputs machine specific instructions. Okay, so the JVM takes in bytecode and then it produces as output instructions that my machine, my hardware can understand. If you're running on Windows, you have a Windows JVM, and your JVM takes in bytecode and it outputs instructions that your machine can understand, so that your Windows hardware can understand. So each of us, our hardware is slightly different. And so this is Java's solution to, I guess, that difference. Now, there are some programming languages, and there's, for example, a programming language called C, and C does not have this intermediate step. So for C, you have to download a compiler specific to your machine. And then you take source code, you put it in the compiler, it skips over this step, and it just outputs machine-specific instructions. And the downside of that, it means if I wrote a nice program in C and I compile it, you cannot use it. Okay, so for C, I'd have to just give you my source code and then you could compile it on your own. Okay, so from the very beginning when Java was created, they really made sure that it was nice and universal and independent of any particular machine. So we could just pass out class files and then each of us has our own specific JVM and it translates for us. Okay, last but not least, I want to talk about where can this go wrong. So there are a few different places in this flowchart, some of which you are familiar with, where things can go wrong. And the first place, which you are all familiar with, is the compiler. Okay, so one thing that could happen is that you could get a compile time error. Okay, and so this means you have a syntax error. We saw one of these today where it said, hey, I cannot apply the method to these types. The method requires one double and you are passing in two doubles. So the formal and the actual argument lists differ in length. That's a compile time error. Okay, so things are not lining up. Your types don't line up. Your method header does not agree with how you called the method. You left off a semicolon. You didn't close a curly bracket. So there's something syntax-wise happening. Okay, other times you get lucky, it passes the compiler, it compiles perfectly, and then you go to run it, and then your program crashes, or you get some sort of error at runtime. Okay, so that is known as a runtime error. Okay. So this is an error that happens during runtime. And it causes the program to crash. We've seen examples of this, so either having no main method. That was a very nice and gentle runtime error. The program didn't crash necessarily, but as soon as the Java virtual machine realized you don't have a main method, it very nicely shut everything down and printed out a message saying, hey, I can't run this program. There are other runtime errors, actually most runtime errors, where literally your program just crashes, just the end. Okay, so for example, like dividing by 0. Thankfully, at this point in time in 2021, computers are robust enough that you can write a program that crashes and it honestly doesn't affect anything. I mean, the worst thing that happens is BlueJ prints out a bunch of error messages in red and the end. In the early days of computer, writing a program that crashed could literally damage your computer. And so I think there's still like a lingering nervousness sometimes when we start programming that if I crash my program, something horrible will happen. The worst thing that will happen is maybe your machine might slow down a little bit. It might get a little spotty, but machines are pretty robust. So go ahead, crash your program. You will crash your program dozens of times. You don't need to worry about it. Okay, last but not least, you make it through the JVM and you run your program, it doesn't crash, and you look at the output and the output is wrong. And that is known as a logical error. Okay, so your program runs successfully, but it produces incorrect results. And in lab yesterday, many of you had logical errors. So, I saw that your code compiled, you ran it, it printed, and all the numbers were wrong. Okay, so that's a logical error. It just means you have an error somewhere in your math or in the steps, your algorithm. And so then you have to go back and figure out where the logical error exists. So those are the 3 types of errors that you could have, and we've seen, and you are probably already familiar with at least 2 of those 3 types, compile time and logical errors. As the semester goes on, you'll get lots more runtime errors. And go from there. Okay, let's stop again. Finish writing down anything you've not written down. Look at this flow chart and the different types of errors, and spend some time thinking to yourself, any questions, any clarifications, any what if questions. Those are also fun to answer. Okay, any questions?
I just have like kind of like a question about the logical errors. So it seems like logical errors might be like the hardest to spot because it seems like it's like right because everything went through. So
Yeah.
how would you recommend us like finding the error within our code for those logical errors?
Okay, that is actually a fantastic question. That is actually a fantastic question because one, you are right, they are the hardest errors. And two, because we're writing methods and our code is getting more sophisticated, I should have said this. You will notice in the lab and in the homeworks, I provide examples of my inputs and my outputs. So for yesterday's lab, I said, okay, hey, if I start with $100, then after the first year, it should be 105 and then 110, and I gave you outputs. Those are known as unit tests. And unit tests are what computer scientists use to track down logical errors. So literally, you will get a sheet of paper, a calculator, sit down, compute a few values by hand, and then run your code and compare it against what you've done. Those are known as unit tests. I often will give you unit tests for your code kind of hidden in there so that you can make sure you don't have any logical errors. Yeah, that was a great question. Any other questions?
Is BlueJ in general any better or worse than other programs for avoiding computers crashing? Because I broke mine with Arduino code.
Any normal IDE, by which I mean not like an Arduino one. So like there's a lot of IDEs out there. So I showed you like Sublime that kind of accidentally popped up on me, or Eclipse or IntelliJ. All mainstream IDEs do a really good job of like shielding your computer from the worst effects. Now, when I took my Intro CS class, my professor wrote a piece of code where he asked for some memory. I think it was like for a number he was storing, but he accidentally asked for it repeatedly without end. So we're gonna learn how to do loops, and loops just do the same piece of code again and again. And inside the loop, he just asked for memory and completely crashed his computer. At that point, there's really nothing that BlueJ can do, right? It just executes your code. And at some point he had used up all of his memory. His computer like slowed down massively and just crashed. So there are certain things you can do to like actually trigger serious like problems with your computer, but for the most part, yeah, BlueJ and other IDs really try to buffer that, so you don't have to worry so much. Yeah. Okay, well, I just want to end by reiterating, I think methods are the first concept that we're covering in this class that are a little deep, and we're stepping away from our cozy blanket, which is I have numbers and I see my numbers and I do things to my numbers and I love my numbers, and we're really separating it out into the abstract. And then in main, you can pass in the numbers like you want. And I think conceptually that's very hard. In fact, our lab tech Emma yesterday was trying to like kind of lecture me, you know, this is why it's hard, and help me to remember what it was like. So to that effect, if your experience after lab was like, okay, that was kind of confusing and I feel like I'm not really sure what methods are, it's kind of like, that's kind of where you should be. And lab was supposed to give you 2 hours of just wading through it, getting into the thick of it. And then hopefully now that you've seen my solution, that kind of provides some mental clarity, and you can start the homework assignment, and the tutoring is up and running in our department in CWOT, and you can contact me. Okay, so I guess I'm trying to say, like, don't shy away from the that feeling inside of like, I don't like the way this feels. It's not a good feeling. You kind of have to like work through that. Yeah. Okay, that is that. I will post this video lecture on our course webpage. If you guys have any questions, you can email or email. It's basically it. You can't come to my office, and I will see you all on Monday then.